Okay, have you guys seen this video? Did they show it to you on Monday? No one showed it to you? Every faculty member got emailed this and was asked to show it to you on Monday. Oh, you can read it. Okay. I think there was more to that video. I don't know why PowerPoint keeps on cutting it off early, but there is more to that video. Basically, it's summarized here, though. So you can ask for academic consideration from CISC220. I forget what that stands for. Basically, normally when you ask for academic accommodation, they ask for proof or some sort of evidence that you are actually sick, right? So they ask for supporting documentation. You're allowed a 1 3-day request without supporting documentation. Right, so if you're sick for some reason, don't go to the doctor, right? Not the first time anyway, right? Don't go to the doctor if you feel you don't have to go to the doctor, right? Just fill in the form, send it to them. They'll let me know that you can have up to 3 days for whatever, right? Maybe you'll miss the midterm. Maybe you'll have to hand in something late, something like that, right? There's their website right there. They've tried to streamline stuff so it's easier to find information. You can actually contact them directly if you need to talk to somebody via a phone number, or you can just email them, right? So they're trying to make this easier for you to discourage people from coming to class or coming onto campus if you're not feeling well, right, for whatever reason. And I guess speaking about not feeling well, I apologize for Monday, but I was not feeling well on Monday, and I really could not give that lecture on Monday. I was here, but I just couldn't do it. So I went home. So sorry about that. Oh, I was feeling awful. But anyway, not COVID related, so it's okay. So I just want to review a few things from the previous lecture. So that would have been last Thursday, so it's a while ago now. Using the single square brackets, right? That's the test command, right? You can evaluate, you can compare integers, right? Now comparing integers, if you do it this way, and I don't actually recommend you do it this way, but if you do it this way, you have to use this dash character for the operator, right? So dash EQ is equal dash NE not equal, and so on, right? And the arguments have to be integers. Well, that's not exactly true, as you'll see in a moment, right? Because bash does weird things if you don't give it integers. So, for example, if you want to check, so here's that test string example. I'm just showing you how to compare strings, right? So I want to check, are the number of input arguments 0, right? So $pound or $hashtag, right? That's the number of input arguments, right? Dash EQ equal to 0, right? If it's not, then I'm going to send a message to standard output, to standard error. And I'll explain that again too, that dollar and two. I'll explain that in just a second. Right, so that's how you can check if the number of input arguments is equal to 0, right? And of course, you can check any other number of you can check any other condition on the number of input arguments, right? You might write a script that requires 2 input arguments, so you know if it's not equal to 2, then output some error message, right, or something like that. Now that funny notation, that greater than and then 2, right? So what echo does, echo sends missing argument to standard output, right, by default. Right? Now what I want to do is I want to redirect standard output to standard error because this is an error message, right? And I went back and looked at the slides and I realized I never actually showed you how to do that, right? So we know how to redirect stuff to a file, right? So I know how to redirect standard output to a file. I know how to redirect standard error to a file, right? I never told you how do you redirect standard output to a different stream, right? And so the way you do it is you use the redirection, and then it's and to, so redirect to stream 2, right? And stream 2 is standard error, right? So that's how you should be outputting your error messages if you're using echo, right? Or if so whenever you need to redirect your message to standard error, did you get it? Oh, too bad. It's and to, right? So that does the redirection. Right, and there's the slide that tells you that. Okay, so that's what that notation is doing. Okay, using these arithmetic tests, right, these integer tests, you can do things like test a number for evenness, right? So for example, if I get a number, if I get more than 0 input arguments, right, I can take the argument, right, so that's $1, and then I can use my arithmetic expansion here, right? So $, round bracket, right? Now I can use an arithmetic expression in here, right? So percent is the mod operator in bash, right? So essentially it's remainder, right? So if the remainder after dividing val by 2 is equal to 0, then I'm going to exit. So that will give you a exit value of 0, right? Otherwise, it exits as 1, so it exits with a non-zero number, right? And up here, if you feed it the wrong number of arguments, it also exits with a non-zero number, right? So the exit value is 0 if the number is even, and it's not 0 if the number is not 0 if the number is odd, right? Notice there's a warning down here. This script is buggy, so you can make it break in a fairly easy way. Right. So let's give it a try. So this is even. I just want to make sure it's actually here. Oh, I should tell you, if you're copying and pasting the slides, you have to be careful. So I just did it earlier, before the class. I copied and pasted a few of the slides, the code from some of the slides. It's probably not going to work. And it's not going to work for a very mysterious reason. It's going to look right. So here's is even 4, for example. Right? I fixed this now, but it looks exactly right. So when you copy and paste the PowerPoint into your slide, it's going to look right. But the encoding is going to be wrong. So things that look like round brackets aren't actually round brackets as far as bash is concerned. So you have to be a little bit careful. I'm going to post the code so that you can download it instead of having to type it all in yourself. But for now, if you want to run it right away, you have to type it in yourself. Don't copy and paste the PowerPoint because it's probably not going to work. Right, is even. Here. Okay, so let's try this. Now, is even's a little weird because it doesn't print a value. It doesn't echo anything, print anything to standard output, right? So if I do is even and 0, right, you get nothing, right? So what is even is doing is it's setting the return value, right, or the exit value. So what you have to do is you need to look at the exit value, right? So you have to echo $? Right? So $? That's the exit value from the last command that you ran, right? You're allowed to use semicolons to separate commands in bash. So I'm going to run is even 0, and then I'm going to echo the result, right? You're going to get 0, which is good, right? Oops, sorry. I'm going to do 1, which should be something else, right? So it's non-zero, which means it's not even, right? Now I said this is a buggy script. Why is it buggy? Because if I type in a string, apparently the string is even, and regardless of what the string is, right? It's always even. It doesn't matter what string you put in. If it's not numbers, you'll get something funny, right? You'll get 0. And that's because, right? So that's if you feed in a string as val, bash converts the string to 0, right? Which is very strange. There's no error, right? It's silent. It just keeps on going. And so that script is buggy because it will accept string input or textual input that's not, or non-numeric input, and it'll still give you an answer, right? When it really should be outputting some other non-zero value. So you have to be a bit careful about that. And I'll show you how to fix that shortly. Okay, so I've told you how to use the single bracket, right, or the test command and now I'm going to tell you not to use it. Right? But you'll see it in scripts. Right? So if you go and look at other people's scripts, you will see the single bracket, so you need to know what it's trying to do. In modern versions of Bash, so anything beyond Bash 3, you're probably using 4 or 5, or 3 point something. Right? Those are all fine. They have this double bracket expression. Right? So the double bracket test expression is much easier to use. Right? And it actually provides more functionality than the single square brackets. Right? So you should really prefer the double square brackets. You have to remember that when you use the double square brackets, there's no word splitting. Right? So in other words, if you have a variable that's in the double square brackets, you don't have to quote it with double quotes because Bash won't break the word, it won't do any word splitting on the variable anyway. Similarly, it won't do any file name expansion. So if you have a star or a question mark or something like that, it won't be interpreted as a file name expansion. Right? All the other expansions are performed, which means you can do arithmetic expansions and command expansions, right? And variable expansions. Now, the really nice thing is that you don't have to escape less than and greater than, right? They behave less than and greater than. You can actually use them to compare numbers, which is nice, right? You don't have to use -LT or -GT. What else can you do? You can compare strings, right? So I can compare two strings for equality, but I can also use wildcards now, right? So I can use wildcards for the pattern matching. So I can say string 1 equals S star, right? And now string 1 will match any string. That will match as long as string 1 starts with an S, right? So now you can do this wildcard expansion as well when you do string matching. But the really powerful thing you can do is the last thing. So you can do what's called regular expression matching. And that's what I'm going to spend most of this lecture on. Right? OK, so let's see an example of using the double square brackets. Right? So double square brackets. Right? That test is the same. So you can still use EQ if you want to. But you can also use equals there. Right? Here, right? If you look at the previous version of the script, I had to enclose the $S inside double quotes. Right? So we go back somewhere here, right? It's in double quotes, right? And that's because if you don't enclose it in double quotes, Bash does word splitting, right? And you don't want the word splitting there, right? And here, right, if you go back a few slides again, right, I have to enclose the S in double quotes to prevent word splitting. Right? I have to escape the less than, right? Now you don't have to do any of that, right? You can just write $S less than n, right? And away you go, right? So that compares the string S to the string n, the letter n, right? If S comes before n, then it writes before n, right? Otherwise, it writes after n. It really should be n or after, but that works too. Right? So the double brackets is it's much easier to use, right? And it's much safer to use. It prevents all these weird errors that you run into when you forget to double quote something or when you forget to escape a less than or a greater than sign. OK, now you can also use the double round brackets if you're doing integer arithmetic tests, right? So for integer arithmetic truth tests or comparisons, right, you can use the double round brackets instead of the double square brackets. Right? And you can do all of the usual arithmetic comparisons, right? Less than or equal to, greater than or equal to. What you have to be a little bit aware of is that there is a precedence to these operators, right? So these are grouped by color, right? So the first 4, they all have the same precedence, right? The next 2 have lower precedence than the first 4, right? Logical AND has higher precedence than logical OR. And then there's the ternary operator, which I'm going to skip for now. If you know what the ternary operator is, it's more or less the same thing in Bash. Right? It's basically an easy way to write if-else, or a shorter way of writing if-else. OK, so now you have all of the usual arithmetic comparisons as well, which is nice, because now you can write arithmetic the way you want to instead of using -NE or -EQ or -GT or something like that, right? Now, what you have to remember is that now the rules change. So before, if a command has an exit value of 0, that's considered true, right? If you downloaded the slides from the websites, they're wrong. I caught this error like 10 or 20 minutes ago. So if a command has an exit status of 0, it's considered true. If it's non-zero, it's considered false. Now it's the opposite, right? So if you're doing these arithmetic comparisons, then 0 is considered false, and non-zero is considered true, right? So that's opposite to how the exit status is interpreted, right? So if you write if round bracket 1, right? 1 is considered to be true, right? So this will print true, right? If you write if round bracket 0, 0 is considered to be false, right? So this will echo false, right? So now it's the opposite to how the exit statuses work. Apparently that's to be consistent with how mathematicians interpret 0 and non-zero. We'll just go with that, right? Okay, so test for evenness using an arithmetic expansion. So this is the third version of is even, right? And this one, we'll get to this in a second. So now I'm going to use the arithmetic comparison here. So round bracket, right? Dollar hashtag equals 0. So the number of input arguments, right? If the number of input arguments is 0, I'm going to exit with the value 2. Skip over this for a second. Down here, right? I'm going to use the round brackets again. Notice space doesn't matter inside the round brackets, right? So here I've got a space after the round bracket. Here I don't. It doesn't matter. Bash doesn't care now that you're in round brackets, right? So double round bracket. Take the remainder of dividing val by 2. If that's 0, then we're going to exit with 0, right? So apparently, so if you can divide by 2, the answer is true. Otherwise, we're going to exit with 1, so you have an odd number, right? And now this script, that if statement here, is checking whether or not your argument is an integer or not, right? So in other words, it's checking if your argument's a string, right? So what do? Okay, so inside the single square brackets, right, not the double square brackets, the single square brackets, right, I'm going to double quote $val, right? I'm going to check, is it equal to $val, right? Now, if val is a number, so if it's an integer, that'll be true, right? So something, so 1 is equal to 1, right? And I have a not in front, right? So the body of the if statement will not run. Right, and it'll just keep on going on its merry way. Now, in current versions of Bash, if val is a string, right, then this will fail with an error. So string dash eq string inside single square brackets will fail with an error, right? But this is not guaranteed to work in the future, right? So this is how, for the time being, I'm going to check, is the argument a string or not? Right? And it does work. Right? So back here, this is even 3. Right? So there's is even 3. If we run that, I'm just going to do that. Okay, so if I give A, B, C, D to is even 3, you will see the error message appear. Right? And you can even see why this works, right? So Bash tells you, right, on line 8, that thing A, B, C, D, that's supposed to be an integer expression, right? And you gave it a string, right? And then my message comes out saying the argument's not an integer, right? So now the script is not buggy anymore. Yes?
If you wanted to, like, you kind of handle the error in the code.
Yeah.
So if you wanted to get rid of the line that comes, like the error line.
Yeah.
Is there a way to do that?
Is there a way to do that? Yes. There is, in fact, a way to do that. It's debatable whether you should do that, but there is a way to do it. And now I have to remember how you do it. So, well, I'm going to try it on the fly, but I make no promises if this is going to work. So what you want to do is you want to take the comparison here, right? So you have the comparison, so that's actually a command. Right? That command fails with an error. So what you want to do is you want to take standard error and you want to dump it somewhere else. Right? So let's hope I can do this. 2 colon, oh wait, not there. Right, so I want to take, up, there, 2 colon. Right, so 2, okay, no, wrong one. Here, there we go. I'm going to take standard error. I'm going to redirect it to root dev null. Dev null you can think of as being a dumping ground for everything. Let's hope this works. Hey, I got it. All right, that's good. Right. I don't normally program in Bash, so the fact that I got that's pretty amazing. But yes, that's how you do it. Right, so, oops, sorry. Let me go back and just review that again. Right, so all of this stuff here gets evaluated as a command, right? If it fails with an error, the message goes to standard error. So I take standard error, right, and redirect that to a file called dev null. Right? Dev null is basically you're throwing stuff into the garbage. So basically, nothing happens. It just goes away, right? So it goes into the ether and gets discarded. So if you want to get rid of the error message, that's the way to do it. Yeah. Good question. All right, let's carry on. Oh, here. So I'm explaining what's going on. Now the problem is this only works in current versions of Bash, right? And it's not guaranteed to work in future versions of Bash. And it probably doesn't work on most other shells, including the Mac Z shell. So if you try that on Z shell, I don't know if it works, right? You probably get 0, right? It probably converts val to 0. But I don't know exactly what it does. What you really want to do is you really want to check, is val an integer, right? And so the way we're going to do that is with what's called a regular expression. OK, what are regular expressions? Have you done regular expressions before? Anybody? Some? One? Anybody else? Yeah, a few of you, right? OK, so you don't normally see them in 121. You normally don't see them in 124, although you could. So now is the time to talk about regular expressions, because they show up everywhere. So a regular expression, or regex for short, it's just a sequence of characters that specifies a pattern, right? So it defines a pattern. Now, the interesting thing about this is that the idea comes from theoretical computer science and formal language theory. So the people who actually study how you write, how you create a language for a computer, this is where the idea came from, right? So theoretical computer science is in fact useful. Used anywhere you want to search for text that matches a pattern, and you can imagine there's lots of times when you want to match some kind of pattern, right? So you can do stuff like, you're given a string, does that string represent, or does that string look like a URL, right? Does that string look like a student number? Does that string look like a date? Does that string look like a social insurance number, right? Does that string look like an IP address? And so on, and so on, and so on, right? As long as you can specify what the pattern is you're trying to match, you can use a regex. Having said that, if you can specify a pattern, it doesn't mean you should use a regex, okay? So if you can look up the regular expression that you need to match email addresses, and it's ginormous, right? So just because you can do it doesn't mean you should do it, right? But in your free time, Google how to match an email address via regular expression, and you will find, eventually you'll find the one that actually works, right? Bash uses a particular flavor of regular expressions. It's called the POSIX extended regular expression syntax, right? So there's many flavors of regular expressions. OK. Now, how do you use this? How do you do regular expression matching in Bash? You use the double square brackets, and then you use this funny equals tilde operator, right? So given a string, you can check if that string matches that regular expression. So RE is another string, right? The string that defines the regular expression, right? So if that thing is true, right, then it matches. Otherwise, it doesn't match, right? And you can, of course, write a little script that includes this if statement like that, right? So here's test regex. It takes 2 arguments, right? So a string and another string that represents a regular expression, and it tests if the string matches that regular expression, right? Using that little if statement there, right? And I have the program on my computer here, and we'll try it out in a second. OK, here we go. This is page 1 of the POSIX extended regular expression syntax. All right. Actually, yeah, so hang on. Let's try this little program first. So we're going to do what I call test regex or something like that. Yeah, OK. So the way you use this program is you type in test regex, then you type in a string, so ABC, And I want to know, does the string match the string ABC? Hopefully this prints true. It does, right? So it matches. Now, what this is really doing is it's checking, does this string, right, does the first string contain the second string? Okay? That's what so if you type in the regular expression just as ABC, right, then it's checking for containment. So in other words, if I write x, y, z in front, and then 1, 2, 3, right, that string will match that regular expression. Right? So here it's checking for does the string is the regular expression, does the string contain the regular expression? Right? So that matches. Now there is a way to force the regular expression to strictly match, right? And I'll show you that in a second. But here we go. Okay, so the caret, right, is called an anchor. Right? So if the caret is at the front of the regular expression, right, then that matches the beginning of the string. Right? Then there's a dollar sign, which is the second anchor. Right? If the dollar sign is at the end of the regular expression, right, then that matches the end of the string. So what the heck does that mean? Right? So what it means is, right, so if I put a caret in front, right, then this string will match that regular expression only if this string starts with ABC. Right? So does it start with ABC? The answer is no. If I make it start with ABC, though, right? Now the answer is yes. Okay? So caret means you want to start the match at the beginning of the string. Right? The dollar sign means you want to end the match. So, oops, dollar. Right? So now, right, so the strings that match this regular expression are the strings that end with ABC. Right? So ABC 1, 2, 3 does not end with ABC, so there's no match. Right? But 1, 2, 3 ABC does end with ABC, so it does match. Right? Now, if you want to do strict word matching, you need the caret and the dollar sign. Right? So that matches the string ABC exactly. Right? So this will not match. Right? That will not match. Right? But ABC will match. Actually, only ABC matches. Right? So that's what the anchors do. Probably the most common error when you write a regular expression is you forget the anchors. Right? And then you end up with strings that match that you don't want to match. Okay, the period matches any single character. Right? So that will match anything, any single character. Square brackets. It's called a bracket expression. Right? So that will match any character inside the square brackets. I guess we should do the period. Let's go and do the period, see what's going on with there. Control L. Okay, so if I do that, right, then A, any character, C. Right? But there has to be a character. Right? So there has to be something there. Right? So that will match ABC, right? Because the period will match with the B. Right? This should not match, right? Because you're missing that middle character. Right? A1 matches, right? And because I don't have the anchors, I can, as long as there's some string inside the first string that matches that pattern, it will match. Oh, wait, that should match. A1C. Oh, sorry? Oh, yeah, I have the ending anchor. Thank you. There you go. There you go. So that matches. Right? Okay, square brackets. So square brackets lets you specify which characters should match. Right? So instead of any character, you can specify a finite number of characters or a range that matches. Right? So let's take a look at that. So instead of the dot, I'm going to say 1, 2, 3. Right? So that will match A1C, A2C, A3C. Right? So if any one of those three strings are part of the first string, you'll get a match. Right? Change the 1 to a 2, you get a match. Right? Change it to something else, like 6, you will not get a match. Right? if you put the caret as the first character inside the square brackets, that negates the match, right? So it matches any character that's not inside the square brackets, right? But it has to be the first character. If it's not the first character, then it's just the caret. Round brackets, so you can group sub-expressions in your regular expression using round brackets. That's useful, you'll see shortly. And then you have what are called the quantifiers, right? So star matches the preceding element 0 or more times. Right? Question mark matches the preceding element 0 or 1 time. And plus matches the preceding element 1 or more times. Right? And then there's a general quantifier. So squiggly brackets m comma n matches the preceding element at least m, but not more than n times. Right? So m through n times. And there's actually, you can actually generalize that a bit. And then there's a choice operator. Right? So that's basically or. And I'll show you that in just a second. OK, so here I've got a bunch of examples. So it might be a little easier just to look at the examples now. Right? So this is my regular expression, right? This column here. This column here tells you what matches the regular expression, right? So if your regex is just hello, no anchors, then any string containing the substring hello will match that regex, right? If you want to match the string hello exactly, then it's the caret and the $sign at the end, right? Caret in front, $sign at end. So that only matches hello, right? Dot matches anything, right? Any non-empty character, right? So that will match 1, LO, A, LO, jello, and many, many, many more, right? You can use the dot more than once, right? So dot dot means H followed by any 2 characters followed by LO, right? S and then square bracket AEI followed by a T means SAT, right? So any character in the square brackets as the middle character. So SET and SIT all match. Right? Now you can also use ranges. So the range is funny here because the way you write the range is different than the way you write the range when you use the braces. Right? So remember there's a brace expansion. Right? Right? And if you want to write a range in the brace expansion, it's A dot dot Z. Right? Now the syntax changes. So if it's a regular expression, it's A minus Z. So that matches anything where the middle character is A through little z. Right? So SAT, SBT, SCT, and so on, up to SZT. Right? Minus sign. So can you match the minus sign? Yes, right? Or the hyphen. But it has to be the first character in the range. Right? If you put it anywhere else, then it has to be the first or the last. Right? So that will also match S hyphen T. So there's this problem that there are some special characters that you use. And so if you want to match those special characters, they either have to be in a particular place or you have to escape them. Oh, sorry. File, here's one. File square brackets 0 through 9, that matches file 0, file 1, file 2, up to file 9. Right? Now, if you want to match the period, right, you have to put it inside square brackets. Right? So if you really want to match the period and only the period, right, then it goes inside square brackets, right? So that will only match A period C. Okay, here we go. These are the quantifiers now, right? So the quantifiers. Remember, star means 0 or more, right? And it affects the thing that's in front of it, right? So dot matches anything, right? Dot star means match anything 0 or more times, right? Any single character 0 or more times. So any single character 0 or more times. So 0 means it's the empty string, right? Any character 1 or more times means basically every other string, right? So that will match anything. Right? Dot plus, right? So plus means 0 or, wait, what does it mean? Plus is 0 or 1, right? Yeah, 0 or 1. So dot plus, right? Matches every non-empty string. Oh, sorry, not every non-empty string. That should be.
Plus means 1 or more.
Did I get it wrong? Plus is 1 or more. Sorry, thank you. Right. So dot plus means 1 or more. right? So dot means there has to be a character there one or more times, right? So any non-empty string, right? Dot question mark, so question mark means 0 or 1, right? So the empty string or every string of length 1. Okay, so 0 through 9, we know that's 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? Now there's no anchors on it, right? So that matches any string that has a digit somewhere inside of it, right? If you write the plus sign, that means any string containing at least one unsigned digit, one signed integer, so no longer necessarily a digit, right? So if it contains some sequence of digits, that will match, right? But it'll also match, so it'll match, for example, A, 1, 2, 3, B, so that matches, right? Now, I'm trying to work our way to how do I match an integer, right? So if I put the anchors in now, right? So if I put the caret and the dollar sign in, right? So now the number must start with a 0 through 9, right? And it should have one or more digits, one or more of those values, right? So that's any unsigned integer, right? You're not allowed the plus sign or the minus sign yet, right? I can allow the minus sign in by just making the minus sign the first character, right? So now I've got any negative integer, right? If I use the square brackets to create a, I forget the name, to create a bracket expression, right? I can now allow question mark is 0 or more, 0 or 1 of these things, right? So 0 or 1 hyphen, 0 or 1 minus sign or plus sign in front of one or more digits, right? So that's any signed integer now, right? Any signed or unsigned integer, right? So it can have the minus sign in front, it can have the plus sign in front, or it can have neither in front, right? And so that's how you match, right there, any integer number, right? Now, you're also allowed to use the POSIX character classes, right? So remember when we talked about these, I guess a week or so ago, right? You can use the square brackets and then the colon and then digit, so that represents any digit. So if you want to write it that way, that's fine too, right? There's also alpha, alpha num, and a bunch of others of predefined character classes. Okay, there's a bunch more, there's still more quantifiers. So inside the braces, the previous slide said mn, right? So it said m comma n, but the comma and the n are optional, right? So in other words, you can have them or not. So you can either put them in or not. So if I just have the 1, so just the m, then that matches exactly 1a, right? So that matches x, that matches 1xa, right? So everything in front of the quantifier will match, right? So that matches xa. If you have the comma but no n, then that means 1 or more, right? So that's x followed by 1 or more a's. If you have a comma followed by a number, that means now, so 1 comma 3 means 1, 2, or 3 a's, right? So xa, xaa, or xaaa, right? So it only affects the thing that's in front of it, right? So it only affects the a. Here's the round brackets. So the round brackets, right, that defines a sub-expression, okay? So the round brackets around ABC with a plus sign after it means, so now the plus sign affects the whole thing in front of it, everything in front of it that's in the round brackets, right? So in other words, this plus sign means 1 or more ABCs, right? So it matches ABC, 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 right? And so on, right? Notice that the previous ones, that quantifier only affects the A, right? Okay, so now, when you go back and test for evenness, right? So now you replace your test with a regular expression test, right? So if val matches the regular expression, right? So starting with 0 or 1, plus or minus signs, right, followed by one or more digits, right? So in other words, is val an integer, right? If it's not, so the negation in front, then you get the error message, right? And now you don't have to worry about trying to, now you're not worried about unspecified behavior on what EQ actually does, right? Because that might change in the future. This will work in any shell that understands regular expressions. Whew. Okay, let's look at some more examples, because so regular expressions are hard to write, right? They're very tricky to write right. Okay, so what does the bar do? So the bar is basically or, right? So caret b bar cat dollar sign, right? So the bar means b or c, right? So it affects the two things on either side of it, right? So that means bat or cat, right? A bar a means every string that starts or ends with an a. Wait, that's not right. A or a. That's basically a. The quantifiers aren't supposed to be there. Wait, no, that's not right. A or a. That's wrong. I'll have to fix that. That's not correct. Every string that starts or ends with a. That'll only match a, I think. But we can test because we've got our handy program here. So test regex. So a, and it starts with a or. Oh no. Oh, hang on. It is right. Yes. Now I know what it's doing. Okay. The or means any string that starts with a or any string that ends with a. So it is right. Oh wait, what did I do? Test regex probably in strings. In quotes? There, yes, there we go. Okay, so anything that starts with a. Oh, so it does match. That's good. All right, so or ends with a. Right. So the or there is capturing the full expression in front and the full expression in the back. Right. So it's not the only thing in front and it's not the thing immediately in front and the thing immediately behind it. Right. Oh, sorry. So ABC or XYZ, so anything that starts with ABC or ends with XYZ. Right? Here, now that I've got the round brackets, so now it only affects the thing in front. Right? So AB followed by a C, or followed by an X, followed by YZ. Right? And again, the round brackets, right? So the or, so either cat followed by nip, or tins followed by nip. And okay. Finally, how do you match a date? Right. So this is a numeric date, not a written date. Right. So what are all the years between 1900 and 2099? Right. So now this is where you have to figure out how do you write down the pattern. Right. So the first two digits are either 19 or 20. Right. Either 19 or 20. So in round brackets, right, 19 or 20. Right? Now the next digit, the third digit, right, is between 0 and 9. And then the fourth digit is between 0 and 9. Right? You could write this using a quantifier as well. Right? But that's the way many people would write it. Now your month is 0, 1 through 12. Right? So 0, 1, 0, 2, 0, 3, and so on. Right? So this one's a little tricky because you have to deal with the 0. Right? So if you start with a 0, then you're going to follow that with a 1 through 9. Right? Or if you start with a 1, that's going to be 0, 1, or 2. Right? So that one's a bit trickier to write. Now what about the days 0, 1 through 31? Right? So if you start with a 0, right, you're going to follow that with the digits 1 through 9. Right? Or if the day starts with a 1 or 2, you're going to follow that with 0 through 9. Right? Or if it starts with a 3, that's going to be followed by a 0 or a 1. Right? You can write this more compactly as well, because you can merge the 1, 2 with the 0 up here. Right? And then mash them all together. Right? Pick your separator between the day, month, and year. Year, month, and day. Right? And then you can match a date that's written using a regular expression. All right? So the regular expression is very powerful. Pain in the butt to write and debug. But you're going to have to learn how to do it. OK? We're done for today. Yep.